Michelson-Morley's experiment, Kennedy-Thorndike experiment, an advanced version of the Michelson-Morley's Ives-Stilwell experiment, are considered as the three important tests for the special theory of relativity. Michelson-Morley type experiments have been repeated many times with steadily increasing sensitivity. These include experiments from 1902 to 1905 and a series of experiments in the 1920s. More recently, in 2009, visit links in the description. The main objectives of these experiments were the verification of a space-filling substance called ether, but none of them was positive. At the same time, the precession of the perihelion of Mercury, the bending of light in gravitational fields, the gravitational redshift, gravity probe B, Schwarzschild precession, detection of gravitational wave, are considered as some of the important tests for the general theory of relativity. Einstein relied mainly on the result of the Michelson-Morley experiment and developed the special and the general theory of relativity by completely disregarding the possibility of the existence of ether. Therefore, any evidence for such a substance will lead to the re-evaluation of the theory and make relativity in trouble. At the same time, it is interesting to see that all phenomena that are explained or predicted by the theory of relativity can also be explained in a non-relativistic way, just by adding ether into the picture. Now let's see how it works. To do so, first, let's assume 1. Space is filled with ether. 2. Because of the gravitational force of attraction, a massive body maintains a denser region of ether around it. Since gravity decreases with distance, the density of ether will be more near the body and it decreases with increasing distance from the body, just like the density of atmosphere. New explanations. The null result of the Michelson-Morley experiment. Because Earth holds a denser region around it, this region acts as a shield. Therefore, the light beams in the interferometer will be traveling through a stationary space, and in effect, the interferometer will not work. Time dilation due to gravity. Since the greater density of ether in a gravitational field, a moving/vibrating particle will experience a drag force. A high gravity generates a high drag and vice versa. When the electrons in the atoms of an atomic clock of a GPS system vibrate, because of the low dragging effect in space, their frequency becomes high, and the clock ticks faster. Conversely, because of the high density of ether on Earth's surface, a similar clock on Earth ticks at a slower rate. Time dilation due to speed. As the speed increases, the dragging effect also increases, just as the effect of gravity that we discussed above. Therefore, a moving clock ticks at a slower rate than a stationary clock. Gravitational redshift and relativistic Doppler effect. Just as we saw above, a light source, which is situated in a high gravitational field, because the ether density is high in those regions, vibrating particles experience a dragging effect, and the frequency of the emitted radiations becomes low. Therefore, when a light source is passed through a gravitational field, light becomes redshifted. This can create a Doppler effect. Gravity probe B. The effect detected by the gravity probe is the buoyant force of the ether. In fact, the gravity probe detected an effect of the denser region of ether around the Earth. Mass defect and the release of energy. When a mass defect happens, it will detonate and become a thin form of matter, ether. The products in a nuclear reaction get their kinetic energies from this rapid, huge expansion of the missing mass. It turns out that all events in nature that create mass defects release ether to space. Starlight bending gravitational lensing. A star releases a large amount of ether to space continuously. For example, the Sun converts hundreds of billion tons of ordinary matter into ether every day. The release of ether, the Sun's gravitational pull on the released ether, and also the Sun's gravitational pull on the previously existing ether in space, jointly create a denser region around the Sun. A passage of light through this region causes it to refract and bend. The stars in a star cluster collectively create a large-scale light-bending region in space. When these regions are perfectly aligned to an observer and a light source is behind it, the region will act as a light concentrator. Precession of Mercury's orbit. The density of ether in the perihelion region of Mercury's orbit is sufficient to create a buoyant force on Mercury. Therefore, each time when Mercury approaches this region, it will slightly skid forward. This results in the orbital precession of Mercury's orbit. Schwarzschild geodesics. The density of ether in the perihelion region of the closest star to the galactic center black hole is sufficient to create a buoyancy on the star, and each time when the star approaches this region, it will skid forward. This results in the Schwarzschild geodesics. Lorentz contraction and the increasing mass of a moving body. When a body travels through space at high speeds, the dragging effect of the ether compresses the body in the direction of motion. This results in the Lorentz contraction. At the same time, the ether trapped in this contraction process results in the mass to increase. Both of these effects will become more evident as the speed approaches the speed of light. The detected gravitational wave. Perhaps there is a connection between the detected gravitational waves or ripples in space by LIGO and Virgo and the occurrence of a large-scale mass defect in deep space. Perhaps the light beams in the interferometer have been passed through these ripples, and these ripples made the laser beams interfere. Experimental evidence for ether. In 1924, de Broglie published his matter-wave hypothesis. In 1927, Davison and Germer, and independently G.P. Thomson have performed matter-wave experiments, which showed that moving electrons behave like a wave as suggested by de Broglie. This eventually led to the development of a new branch in physics, quantum mechanics. Later experiments with neutrons, atoms, and even molecules demonstrated similar behavior. In the hypothesis, the de Broglie wavelength is the wavelength, lambda, associated with a massive particle, i.e., a particle with mass, as opposed to a massless particle, and is related to its momentum, p, through the Planck constant, h, lambda equals h/p equals h/mv. However, I have a different thought about the result of the matter-wave experiment. In the Davison-Germer experiment, the maximum intensity of electrons diffracted by the atomic surface was observed at an angle theta equals 50 degrees with a voltage of 54 V. That is, in the experiment, by applying 54 electron volts, electrons became like a wave. Here I would like to see it in a different way. Let's assume that electrons are traveling through space, which is filled with a kind of tiny particles. Each time when an electron collides with a particle in space, its path will get disrupted. Therefore, when the electron travels from point A to point B, it will be traveling not in a straight line, but instead, it will be traveling in a turbulent chaotic path. We can measure the wavelength of its path. As the speed increases, its wavelength becomes shorter and vice versa. Similarly, a massive particle's wavelength will be smaller than a lighter particle's, and so on. In fact, this is consistent with the de Broglie wave in every aspect. I suspect that perhaps this is what really happens with a matter-wave experiment. We discussed the possibility that the density of ether near a massive body may be greater and it decreases with increasing distance, and the dragging effect experienced by a moving particle near Earth's surface will be more comparatively than in outer space for the same speed. It leads to the possibility that two similar matter-wave experiments, one on Earth and another in an orbiting satellite, may produce different wavelengths. If this is the case, it may be considered as evidence for ether. I welcome researchers to consider this possibility seriously. Perhaps this simple experiment may revolutionize our perception of the universe forever.